So with the solving equations, we have some fractions that we want to get rid of, and I'm going to multiply it by 3 times 4 everywhere. Try to make my 3's better. 3 times 4. So what I can do here is get rid of the 3's, and I'm left with 4x. If I get rid of the 4's, I'm left with 3 times 3x, or 9x, and this would simply be 24. 2 times 3 times 4. And this adds up to 13x over here. Divide by 13. And x equals 24 over 13. Now that's kind of a strange number. So what we're going to do is we're going to plug that into our calculator just to make sure that it's working. So one of the ways we can do this is if I type in 24 divided by 13, it's not a very nice decimal, so that would be really hard to type in every time. So what we can do then is just do second negative, and remember when you do this, it's the answer divided by, this is a 3. So we're going to take our answer and divide by 3. And then remember the next term is 3x over 4. So I'm going to go 3 times second negative, again, putting my last answer in. And I put that in parentheses so that I can divide it all by 4. And notice when I hit enter, I get the output of 2. So I put the answer here back in for the x, and it equaled 2. So I feel good about my answer. Next one is a DIY. So pause the video now and come back and check the answer. So you can see the person that wrote it this way put a 14 and parentheses around everything. That's another way to do it. So they put a 14 here, divided by 2 leaves the 7, 7x. 14 divided by 7 leaves a 2. 2 times 6x is 12x. And over here, the 14s would get rid of each other, and you're left with 19. So if you add all this up, you're left with x equals 1. So on something like this, I could run 2 times 2 times 4. Those are my denominators, which would be 16. I could use 16 as my common multiple, but a 4 would work. So instead of 4, I'm going to go 2 times 2 everywhere. And this term, we have to pay attention to it. It does not have a denominator, but you still have to multiply it by the 4. So I'm going to switch colors to show that's one mistake that students make, is this, even though it doesn't have a denominator, you still multiply it by everything else. So the 2 times 2 is 4, so I can get rid of that 4, and we have 5x. Get rid of one of the 2's with that 2. 1 times 2 is 2. Nothing gets, we don't cross anything off, so that's 2 times 2 is just 4 times the x, 4x. And again, one of the 2's and a 2, so I'm left with negative 2. Now it's just algebra. Move everything to one side. So I can subtract 4x. And I'm also going to subtract this 2 to the other side. So these 2 will be gone, and we're left with x equals negative 4. So that would be a pretty easy one to plug in for your x's and make sure that both sides equal the same thing. Now they usually get more difficult, and so on this one we start working with polynomials and factors. So remember that if you take the x minus 2 and the x plus 2 and you multiply them, you get x squared minus 2x plus 2x minus 4. But these two things go away, and so you're left with just x squared minus 4. We'll notice that those two things multiply to give you the third denominator here, so that's usually what's happening. So what I'm going to do is write x minus 2 I'm going to write x minus 2 at the top, x plus 2 at the top. So x minus 2 x plus 2 at the top of each one of these. You don't have to write it out this way, it's just I like to for the visual. So what you're going to see is that the x minus 2 crosses off, and I'm left with 1 times x plus 2. And then here the x plus 2 goes away, and the x plus 2 goes away, and that's 3x minus 2. But here the whole thing goes away, and the whole thing goes away, and you're left with minus 6x. So you're going to solve x plus 2 is equal to 3x minus 6. That's equal sign minus 6x. So if I move everything to one side, I can subtract 3x and add 6x. So I can do that over here. And at the same time, I can subtract the 2. So what I'm left with is this right here adds up to 4x. And then this right here adds up to negative 8. Because this will be gone, this will be gone, this will be gone. Divide by 4. X equals negative 2. Now in a problem like this though, when we go back to plug it in, get rid of that. So what we're going to do is we're going to take this negative 2 and you plug it back in wherever you see an x. And one of the issues will be right here. If you put negative 2 in there, you have 3 over 0. And then over here, you'd have 0 and negative. You'd have a negative 12 on top if you put the negative 2 there. And then negative 2 squared is also 4, so 4 minus 4 is 0. Right? These two terms are undefined. So what we're going to do is just do a little dotted line x through it. So that's called an extraneous solution. So if you run into that, you got to be careful. Can't have undefined terms when you plug your answer back in. So the next one is a DIY. So try that one and come back and look at the answer. So pause your video now. So we're going to multiply everything by this. I would write it each time and cross things off. But if the x minus 2 crosses off, x plus 3 times 1, the x plus 3 crosses off, x minus 2 times 3, everything crosses off here. That's how x squared plus x minus 6 factors. And you're left with just 4. Get everything to one side, and you might write down 7/4 or 1.75. On this last one, one other technique you could have used on the problems before is you could have got each side a common denominator and just created 2 rational expressions on both sides. So that's kind of what we have here. And you can just cross multiply. So I can take 3 times the 5x minus 4, and I can take the 2 times 5x plus 4. So top to bottom, bottom to top. So this is 15x minus 12, and this would be 10x plus 8. Get all the x terms, so maybe subtract 10x here, subtract it here, so I get 5x. And I can add 12 and add 12, so that's 20. And then when you divide by 5, x equals 4. So again, you can plug that in and make sure it's working. Now we get back into some quadratics and polynomials, and so you're just going to see some techniques. So follow along. In the first one, we're dealing with a quadratic. We want a quadratic set equal to 0, so bring the 5x over as a negative, so it's x squared minus 5x plus 3. 2 numbers that multiply give you 3 are 1 and 3, but I can't add up to 5. So immediately I'm going to go to the quadratic formula. So x will equal negative b plus or minus the square root of negative b, or b squared, minus 4ac all over 2 times a. So that would be 5, plus or minus. Under the radical, you have 25 minus 12, so that's the square root of 13 all over 2. So you could write that, that's fine. Or some people like to do 5 halves plus or minus the square root of 13 over 2. Split it up into 2 parts. Either way is fine. The next one, you can FOIL the parentheses if you want. 2x minus 1 times 2x minus 1. Bring the 12 over and work with the quadratic. I'm going to square root both sides. Now, the square root of 12 can be broken down into the square root of 4 times the square root of 3, and the square root of 4 is 2. So it's really plus or minus 2 root 3 here. Then I would add 1. And then I can divide everything by 2. So you could leave, again, your answer like it is, or split it up into 1 over 2 plus or minus 2 root 3 over 2. But when you do that, we want to remember I can get rid of those. So maybe one of the best answers would be 1/2 plus or minus root 3. This is what is called factor by grouping. So if you need some extra examples, you can just Google factor by grouping. And so the idea is we'll group these numbers together, and I'm going to pull a 2 and an x squared out. Would leave 2x, would leave just the x, and negative 6 divided by 2 would leave the negative 3, and I already took the x squared out. Now the next one, if you take a 6 out, that will work, but it's going to give you the wrong parentheses. So what we want to do is pull a negative 6 out, and that will leave positive x. 18 divided by negative 6 is negative 3. And so now these two parentheses are the same. So I can pull that out in front and write it as 1x minus 3. And then behind it, the 2x squared minus 6 is left. So now you have a linear factor that you can set equal to 0. So x equals 3. And then here we have a quadratic. Now you can either continue to factor it. You could go to the quadratic formula, or you could set it equal to 0, add 6, divide by 2, square root both sides. That's an easy way to do it too. Go like this. So now when I square root, don't forget my plus or minus square root of 3. So I would add that to my answer over here. So now you could go ahead and put those back in for x to make sure that they are indeed working. And this last one, this 4th degree polynomial, I can split up into x squared and x squared. And if I look for two numbers that multiply to give me 2 but add up to negative 3, I would say 2 and 1. But remember, this positive 2 right here tells me that they have to have the same sign. Well, the only way they're going to add up to negative 3 is if they're both negative. Now, those are both difference of squares. Difference of squares, x squared minus a number. I can factor it into one that's x plus something and one that's x minus something. So the square root of 2 is not a nice number, so I'm going to just write square root of 2. The x squared minus 1 is the same thing. X minus a number x plus a number. But here, the nice thing is 1 is a perfect square. So when you square root 1, you get 1 and 1. And so at the end, my answers are negative root 2, square root of 2, 1, and negative 1.